So today we're looking at a potential slight risk in parts of Oklahoma, that southwest corner, and then into that northwest panhandle of Texas. So what we are expecting is a line of thunderstorms to form all the way from Missouri down to this portion of Texas. And what we're looking at overall is potential squall lines and damaging winds to the north near in that central and northern Oklahoma area, and then not expecting anything huge out of that, but we are potentially looking at an upgrade to some of this. We could see it actually travel a little bit further north, that slight threat. But looking as of right now, the most dangerous storms will be down in this slight zone, and that is because they're going to be indicative of supercell development, which means rotating storms, and that means big time hail and damaging winds and even a low tornado threat. So temperature-wise, it is a very summer day out there. Today we are seeing temperatures in almost the entire nation like we see during most of the summer. We see 90s up into Maine. We see 80s and 90s in the parts of the Midwest and Ohio valleys. The South has been staying about the same, including portions of the Rocky Mountains are seeing these very nice temperatures. And then there's one or two portions of Colorado that are seeing some colder temperatures, but that is of course with elevation. So it's not crazy cold, but just in 2 or 3 spots we could see some of those temperatures dive down lower than the rest. So starting out in the morning hours, we already see this system forming in Kansas. We do see some pop-up showers starting to occur in parts of Texas. And this is going to allow for those daytime storms to really build because they already have a basis to work off of with that humidity due to the moisture. Then looking into the afternoon where most of this initiation will occur, we are seeing more of these bowing segments start to form up in Kansas. So that is your damaging wind threat, is what's going on in Kansas. We are going to see these storms, and this is why I think that this will be actually upgraded and moved a little bit further to the north from a marginal / thunderstorm threat to maybe a marginal to severe threat, to a slight threat. And that's because we are going to see damaging winds along this line. Now, model guidance is kind of so-so right now on what they're trying to agree on with this. This squall line they're saying could be further to the south in Oklahoma, or it could not even happen at all. It could be a group of individual cells. But most of the models are showing a linear fashion, meaning that there will be damaging winds along this line. And we do see the first supercells start to form in the middle of the day in parts of the panhandle of Texas. So then finally at the nighttime hours is where we're going to see this complete system form, and what happens from about 4 p.m. Central Time to about 9 p.m. Central Time is somewhere in there we're going to see some big time supercells form, and they're going to travel and then come together in this complex in the parts of Oklahoma. But we'll see damaging winds right along that Red River, and that's where we can expect most of these storms to have the most severe potential, is on the south side of this. Now looking back to the panhandle of Texas, you note that there are no longer any supercells there. Most of these cells have formed and gone pretty quickly. And what happened during that time is going to be, we're going to have to see in the future hours today, but most likely we are looking at supercell formation roughly 2 p.m. Central Time, and then they're going to be very strong from 2 to about dinner time, and then they're going to start combining with the system from the north, and that's going to allow potential spin-ups along the line, but more damaging winds is the biggest threat there, and then obviously hail due to the supercell environment. So that's it for today. Join us back tomorrow for the weekend forecast. We're going to have that posted for you nice and early tomorrow morning.